All right, so our next set of notes are, it's still compound probability, but it's specifically the addition rule. And there are two versions of the addition rule that we're going to talk about. And we use the addition rule when we are talking about mutually exclusive events, which means they're events that cannot happen at the same time. For example, you can't roll two different numbers on one number cube at the same time. It's impossible. Okay. So you can't roll a 2 and a 5 at the same time. So that means the probability of both A and B happening is 0. So we calculate the probability of A or B happening. Okay. So the multiplication rule is when you want both of them to happen and it's and. The addition rule is when it's impossible for both to happen, so it's or. So our first example, or nope, we still have definition here. So what it looks like in terms of probability is if A and B are mutually exclusive events, then the probability of A and B equals 0, and then the probability of A or B equals the probability of A plus the probability of B. All right, so our first example, let me clear this. So we have student athletes at a local high school may participate in only one sport each season. During the fall season, 28% of student athletes play basketball and 24% are on the swim team. What is the probability that a randomly selected student plays basketball or is on the swim team? So we're trying to find the probability of basketball or swim. Okay. So the probability of somebody playing basketball is 28%. And then we're adding to that the probability that someone is on the swim team, so the 24%. So then 28 plus 24 is 52%, if my math is correct. Oops, it's a really bad 52. So 52%. So 52% of kids in that high school play either basketball or are on the swim team. Yeah. We're actually going to skip this next example because it doesn't really work in this situation. So we're just going to skip it and go to this one. So we have a deck of cards, 52 playing cards. So we want to find the probability of drawing a 4 or a red 2. Yeah, so our probability is 4 or red 2. Okay, so the trick with this one is knowing how many of each of those cards are in a deck of cards. So if you know a deck of cards, if you draw a card with a 4 on it, there are 4 of them. So there's 4 out of 52 4s in a deck of cards. And then we're going to add to that the number of red 2s. So there are 4 of each card, and then 2 of them are red and 2 of them are black. So in this case, there are 2 red 2s. So 2 out of 52. Okay, so we're going to add these together. So 4 plus 2 is 6. And remember, when you're adding fractions, they need to have a common denominator, and that common denominator does not change in your answer. So it's 6 over 52, which we can simplify to 3 over 26. So the probability of drawing a 4 or a red 2 is 3 out of 26. Right. Now, the next type of a probability problem with addition is when there are overlapping events, which means it's events that have outcomes in common. So when that happens, we have to change our addition formula a little bit. So if A and B are overlapping, then the probability of A or B equals the probability of A plus the probability of B minus their overlap. Okay, so this probability of A and B is the overlap. And we're going to talk about it more as the overlap instead of the probability of A and B. Right. So our first example, we have 7 index cards, and each one has the following letters, so A, B, C, D, E, F, G. So we want to find the probability of spelling the words face and cab. Okay. So the word face uses 4 letters. So we're using 4 out of the 7 letters that we have to spell the word face. Right? And then to spell the word cab, we're using 3 out of the 7 letters. Okay. But there's an overlap because face and cab share letters. So they both have an A and they both have a C. So they have an overlap of 2 because that's how many letters they have in common. So they're sharing 2 letters, so the overlap is 2. Now what we do is we add these first 2 and then subtract the overlap. So 4 plus 3 is 7, and 7 minus 2 is 5. So the probability of spelling the words face or cab is 5 out of 7. All right, so moving on to the next example. We want to find the probability of rolling either an even number or a multiple of 3 when rolling a standard number cube. Number cube is the same thing as dice. It's just another way to say that. So let's start with evens. So the even numbers on a die or number cube are 2, 4, and 6. And then the multiples of 3 are 3 and 6. Okay. So the probability of rolling an even number is 1, 2, 3 out of 6. And yes, I know you can simplify that, but don't quite yet. Okay. And then the probability of rolling a multiple of 3 is 2 out of 6. Okay, but their overlap. They both have the 6 in common, so their overlap is 6, which means we're subtracting away 1 out of the 6. So 3 plus 2 is 5, minus 1 is 4. So we have 4 out of 6, which simplifies to 2/3. So the probability of rolling either an even number or a multiple of 3 is 2 out of 3. So moving on. I don't know why I didn't erase these first. So we're going to find the probability of rolling either an odd number or a number less than 4 when rolling a standard number cube. All right, so odd numbers on a dice are 1, 3, and 5. And then less than 4 are 1, 2, and 3. And then their overlap. So they share 1 and 3 in common. So now we're just going to write out the probabilities. So this one is once again 3 out of 6. And then we're adding to that 3 out of 6. And then we're subtracting the 2 out of 6. So 3 plus 3 is 6, minus 2 is 4. So we have 4/6, which we just did and we know simplifies to 2/3. Right. These two just happen to both be 2/3. It's not going to work out every time that you're rolling a dice or a number cube that the answer is going to be 2/3. Make sure you work out the problem. All right, so in a math class, 75% of students visit the ocean and 50% have visited the mountains on vacation before. If 45% of the students have visited the ocean and the mountains on vacation before, what is the probability that a randomly selected student has visited the ocean or the mountains? All right, so we have mountains isn't the first option. So we have ocean, we have mountains, and we have both. In this case, both is the overlap. So it says 75% have visited the ocean. So we're adding that to the percent that have visited the mountains, just 50%. And then we're subtracting away where they've been to both, so 45%. Right, and then this is where calculator comes in handy. But this, I believe, is 80%. So 80% of that math class has visited the ocean or the mountains before. And if we were in the classroom, we would figure out how accurate that number was for our class. But we're not. So just stick to this, I guess. All right, so the last one. On Monday, in Mr. Pearson's class, 12 girls and 12 girls and 15 boys completed their math homework. There are 14 girls and 16 boys in the class. If a student is randomly chosen, what is the probability of choosing a girl or a student who has completed their homework? All right. So we have girl, completed homework, and then their overlap, which is girls who have completed their homework. So the total number from our class comes from this. So if there are 14 girls and 16 boys, 14 plus 16 is 30. And there are 14 girls. So we have 14 out of 30. And then we're adding to that the total number of kids that have completed their homework, which comes from these two numbers. So 12 plus 15 is 27. So 27 out of 30 completed their homework. And now we're going to subtract away the overlap, which means the number of girls that completed their homework. So 12 out of 30 were girls that completed their homework. So 14 plus 27 is 41. And then if you subtract the 12, you get 29. So the probability of choosing a girl or a student that has completed their homework is 29 out of 30. And that 1/30th is the one boy that did not turn in his homework. All right, so that's the last example for this one. Enjoy.